Uh, Let me check this is up and running. Okay, I think we should be good. Okay. This video stream, whatever you want to call it, it's going to be a revision session for paper 3 for GCSE Maths, which I believe is this Wednesday coming. And so the aim of this and what I've done is compiled the questions on past papers and whatnot um, from the topics that haven't come up yet and that do tend to come up most, if not every year. So essentially, now that we've done paper 1 and 2, there's not a lot of topics left, and that's what I kind of done. Took questions from those remaining topics. Again, like I said, we mostly come up and the plan is to go over it. So this should be a good resource for your revision, but not the only resource. I do always say, as boring as it is, you do have to kind of revise everything, even though it's paper 3. You do not know what's going to throw at you. You don't know that sometimes they might bring up the same topic again from other papers. We don't know, but this will still be a good resource, right? Because a lot of these will come up though, however. So it's good to go over it, I guess. And if you still have any weaknesses in these topics anyway, the way I'd look at it is if you're struggling with these questions, I'd probably make it not a priority. Well, I guess priority to make sure you know what I mean. To make sure you become strong at it and practice before Wednesday because these are important topics. So yeah. And I will say before we start, uh, well, every year for the last few years, there has been that one question on one of the papers with a very, very, very nasty geometry circle question. Uh, it could happen this year because there are a lot of topics that they tend to do that aren't assessed yet. In particular, I'm talking about sectors and sector area slash what's it called? The arc length. Um, you got stuff like circle theorems. And weirdly, you still got exact trig values because what they like to do for like these sort of questions, they give like an angle of like 30, 45. Oh, it's the ratio. Of angle like 30, 45, or 60. Um, and then and then you need to do some stuff and the answer's like a third at the end. Um, so that could link in as well. So all of these, they can make a very nasty question, um, based on those sort of topics, those sort of geometric circle topics. So it can happen. Unfortunately, it could happen. I don't know. I don't know if they're tired of it now and they're going to stop doing it this year. But based on recent trends, uh, and it is hard to practice for it because they're quite different. But you just have to be prepared. Is all I'm going to say there. Um, 'Cause they can make a question out of this and of some other topics. Uh, and yeah, and so actually at the end of this, if we get time, there's like a little challenge question on like a sort of nasty circle question. If we get time. If not, I'll do it next time. But we'll get with that as we go along. But I wouldn't worry too much because the likelihood is barely anyone's going to get it full marks, right? So it's not going to affect your boundary to like your the way you get the mark to your certain grade that you want too much, even for grade 9. Like the grade boundary, for example, what 205 out of 244 9, and it goes down from there. Usually that's the ballpark, right? That's not the ballpark, well, I guess, but the maximum sort of. It doesn't really go above this. So you know what? If you lose 4 or 5 marks, I know it's not ideal, but depending on your performance, especially if you got one of the top grades, it might not be the end of the world. But I know that's a lot easier said than done. But if you do want to practice those questions, especially on past papers, it might not be the worst idea, right? Is what I'm saying. Anyway, with that with that warning ahead, I'm going to start with the paper, but I don't know. I mean, it might not be. I think they might this year. I think they might just stop doing that. Um, so maybe there won't be a sort of question like that. I mean, I don't know, but we'll see. Okay, so question one. Then, so we're starting now. Question one. So it's an index law question. Now they haven't done it in paper one. I don't think paper two. They did it very like they did it. They didn't really do it essentially. There was a question that was vaguely with some index laws, but I don't think they've done a full-on question. Well, they kind of did, but it didn't. It wasn't really an actual index law question, I'd say. I don't know. So I think they're going to ask another one, which looks a bit like this. Um, anyway, and anyway, so I'm going to stop waffling now. So that's question one. So the part A, simplify m squared to the power of 3. You should know if you have something that looks like this. So you have something raised to a power, then all raised to another power, you times the two powers together. Okay. So with this in mind, m2 to the 3 is going to be m2 times 3, which is going to be m to the 6. Okay. And then part B, we have to simplify this. So again, going to use some index laws. So x to the 5 times x to the 8. If you're timesing two same numbers together with different powers, again, that's going to go back to this power rule where you add them together, right? So in this case, we're going to add them together. So 5 add 8 is going to be x to the 13. And that's it. Cool. And then part C says expand this bracket here. So because we have a number in the front, we're going to have to times the number in the front, so the 4p, by everything inside. If you want to use FOIL or whatever to help you, but essentially you times both terms, so you're going to have 4p times p squared, and then you get add and then times the second part, so it's going to be then 4p times 3p, okay? And then we can simplify these two bits, right? So then 4p times p squared, that's kind of saying, well, 4p, bear in mind, is saying 4 times p. So this is going to be 4 times p squared. Well, as we did in part B, remember this has a hidden power of 1. Anything on itself has a hidden power of 1, okay? So with that in mind, because we're we're going to use this index law, aren't we? So because again we have the same number times by different powers of 1 and 2, we add them together. So that's going to go to 4p cubed, okay? And then for this bit we can do the same sort of thing. So this is saying 4 times p times 3 times p. So 4 times 3 is 12. And then p times p is going to be p squared, okay? And then we just add the two together. So it's going to be 4p cubed add 12p squared. That's the expanded version, right? Cool. Preferably, if you practice it enough, it should be pretty instantaneous, but you don't have to break it down like that. But I'm just showing it step by step, right? But yeah, hopefully that wasn't too bad. I predict a sort of question like that. And hopefully you've mastered the sort of index law stuff by now. Okay, we're on question 2, and they do ask this most of the time as well. I don't think they've asked a question like this yet. Just stuff with like plans, elevations, and stuff like that. You just kind of know how to do it, really. So it's saying we're given the front elevation and the plan. Okay, so remember what this is saying, right? The front elevation if we stare at it at the front, it's going to look like this, right? Obviously, I'm not drawing it on the grid. That's on the front. Then on the plan, so that's the front elevation. So front, we see it from in the front, right? The plan is the bird's eye view. Okay. Um, and notice here, um, it's kind of telling you how wide it is here, right? Because of the plan, this little line here, this line at the front, you see this line at the front that I'm drawing the arrow between here, this first bit here, that's essentially the front view, right? That's corresponding to this line at the front here. No, sorry, hang on, no. God, let me draw it again. Bit rough. No, the front bit is going to correspond to kind of this top here. But if you look at it from the front, you wouldn't really see this gap here. You know, this little gap here, and but you just see this part, wouldn't you? So that's that again. Is notice how they're both the same. Here, the front elevation here, the width here, and the plan, the width here, they're the same because the plan corresponds to this line of view here. And you wouldn't see the dip from this particular angle. You just see how far wide the shape is. Okay, but what about this side then? Well, this side is telling you how far, how not like the depth. It's really hard to explain this sort of geometric stuff, but basically it's like um, we would see this bit, but then it's 3 cubes wide, right? So it preserves the same sort of shape in the front, but then it's 3 cubes wide. And so the side elevation then, um, well, we're gonna uh, we're gonna be seeing a height of this, right? If you imagine from the front, we'll see a height of this. And how many cubes is that? Well, it's going to correspond to this, right? This height here. So 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. So draw 5 squares, say here. 1, 2, 3, 4, 5. And then we need kind of again how far it would this sort of width then here. Um, and then I guess we stare at the shape again, right? Well, again, it's going to be 3 wide, isn't it? Because this is here is telling you how far like, the shape goes in this way, right? So it's going to be for like 3 squares wide, and it would be like, then it'd be sort of like a rectangle shape that way, right? Because again, if you look at it purely from this side, so the side angle again, you wouldn't really see the dip here. Um, because, for God's sake, didn't mean to do that. Uh, because if you look at it from this side, right, this dip is covered by this top here, this top here. You wouldn't see the dip behind it, but then you'd then see the next when it then goes to the same part here, and then you'd then see up to here. So it'd be again sort of like rectangle shape. So then we connect it. So it'd be look like in that. I probably did a rubbish job of explaining that, but it's so hard to explain this sort of geometric stuff, especially on like a digital thing like this. And for that, I think this is one of the hardest topics in my opinion. I really do, especially someone who's like good at algebra. I don't know. I feel like even the grade 9 students should not overlook topics like this. Anyway, but we're not actually done because we notice there's a little line here. Um, what is that corresponding to? Well, it's actually corresponding to this here, this gap here, if you notice. Um, so actually, we'd still see a rectangle. It will still continue, but there'd be a distinctive line that joins, say here and then here. There'd be like a distinctive line uh, that kind of joins them, and it would be um, and so we need to factor that in, right? So that where this occurs, there's going to be a line here. And so, where would this line be? So the plan is here, but then the side view's here. Um, well, think about it. The side view, again, we see the depth, well, not the depth, of the height here. It's going to correspond to the this here. So it's going to be 1, 2, 3 squared wide. So when it's the third square, so 1, 2, it's going to be here, right? So if you then if it so imagine so basically because what this is going on here is we could whilst we wouldn't see the dip here, we would see like a crease because it's not exactly as smooth and continuous, right? There'd be like a little crease, a little edge. So when there is a gap in our when we can see it, we wouldn't see the gap, but we would see this little crease line here. So when we so from the side, obviously we'd see it go up here, but then when it's 1, 2, 3 squares up, that's where this little gap happens. Okay, that's where we see a crease line, and that corresponds to here. So we have 1, 2, 3. So at the third point, square up, we would have this little crease line. Now, actually, there'll be another crease line if not if you want to call it that. It's going to be here, isn't it? Because that's where whilst it's not a gap down this time, it's where like the two lines before it, so this line and this line, they kind of are a bit bent, right? Because they change, so the two lines will be different. So that would again cause a little crease line. Um, and that's one square up, isn't it? It's here. So when it starts to bend or change to and make a different line, we'll see a crease line because it's really hard to explain this geometric stuff. Because it's not continuous, right? Here, for example, it would be continuous because it's the same straight line. So you wouldn't see any like rough edges or creases or anything like that. But here, because it's not on the same line, when we jump from one line to another, so here, and then we go up here, this here is where it bends, so it has a different line. We would notice that because it would be this little crease line here. Okay, so we'd notice the line are a bit different after one square. Likewise, when this gap happens, and again we go to different line part, we'll then see a at 3 squares apart from the base. We'll see another sort of like difference in like the lines and like the creases, and that would be a side view. Oh my god, right on that. Oh. I don't know. Maybe it's just me, but that was not the nicest question. I'll probably explain it really rubbishly. I apologise, but it's so hard to explain and wrap your head around it visually. I don't know. Anyway, that's the side view. Okay, probably a nicer question now. There we go. Some actual numbers. So CJ worked at a weather station. The table gives information about the temperature at midday for each of the 50 cities in the UK on Tuesday. So then part A is calculate the estimate for the mean. So it's a fairly typical question. We are given a frequency table, and we need to get the mean from it or an estimate. So with normal mean, you just add, the temperature and with the frequency, and then you divide at the end by how many there are. We can't exactly do that here because we don't have the exact numerical, a single number for this because it's a class, it's a it's a grouped data. There is lots of different numbers included here. So we need to pick a particular number to use for the mean for each class. And the best one to use is actually going to be the midpoint, right? We need to consider the midpoint, and you could create another table if you want. They won't probably give you that in the exam though, so you will need to remember to extend it. So the midpoint, and you can add this one. I'll talk about what this fourth one is in a minute. Um, and so then the midpoint, well, what's between 10 and 15? It's going to be 12.5. 15 and 20 is going to be 17.5. 20 and 25 is going to be 22.5. 25 and 30 is going to be 27.5. And 30 and 35 is going to be 32.5. Okay. So what I'm going to do, so like then with a normal mean, you then times the frequency, how many there are by the number, right? And that's what we're going to do here. We're going to do frequency f times midpoint. So what we're going to do is we're going to times these two numbers together for each row, and then go from there. So 2 times 12.5, that's going to be 25. 8 times 17.5 is 140. Let me just draw the other rows here. Uh, then 13 times 22.5 is going to be 292.5. And then 21 times 27.5 is going to be 500 and I'm going to write it. Can I get rid of this? There we go. I forgot to say. I'm going to make it a bit more clearer. There we are. Oh God. 577.5, and then the last number, 6 times 32.5 is going to be 195. Okay, and so then, like with a normal mean, you then need to add them all up, right? And that's what we're going to do. So the sum is going to be 25 add 140 add 292.5 add 577.5 add 195. And so then if we do that, we get 1,230. Okay, and then therefore the mean, well, it's this sum here divided by the number in total. We are given the number in total is 50. If you weren't given it, you'd then just have to add up all the frequencies, right? And that would then get you 50. Okay, depends how nice they are, but normally they do give you the number. But anyway, here we'll just do 1230 over 50. And so your mean would be 24.6. And it's in temperature, so it's going to be in degrees. Okay, and that'll be the mean, that the estimate for the mean. If they do ask you why it's an estimate, the reason then will be because it's grouped. So by nature, we don't have the exact numbers, so it's just an estimate in that sense. Um, So you just say it's group data if they ask for like why it's an estimate. Anyway, so that's it. Alternatively, especially in exam situation, how I would lay this out without drawing all the rubbish tables that I've just done, you could just write the midpoints here, right? So you could then say 12.5, 17.5, 22.5, 27.5, and 32.5, and then just do a times. And then if you wanted to, then you could write it, what it equals here. The examiners will be fine with that, and then obviously add them up as usual. That'd be fine for the examiners. Just how you would lay it out. But I think this is quicker and actually probably a bit better. if I'm if for me anyway. But yeah, so that's how you'd go about the mean for group data. Then it says for part B, the median temperature is 22.5 degrees because 22.5 is the middle number in the middle group. Um, so is he correct? Well, there's two ways of looking at it, I guess. Firstly, we need to check if he's right about 22.5 being the middle group. No, is it in the middle? Is the median in the middle group? So really, this question is going to ask to basically work out the median. So work out the median. So without remember, median is about 50% or half the data, right? So then, with that in mind, well, it's out of 50 in total. So we're going to need to do 50 over 2, okay, and that'd be 25. So we want the 25th number in the frequency. So then, if we then do sort of the cumulative frequency, which means we add them together, it's then going to be 2, then 10, and then 23. So 10 add 13, and 23 add 21 would be 44, and then 44 add 6 would be 50. So then you need to work out, well, where is 25 between? Well, it's going to be here, right? So 23 is the maximum for this. Then 24 would then lie into this category here. So then 24 to 44 will lie in this group. But 25 is between 24 and 44, right? So it's going to be in this class. So actually, he's wrong about the class where the median is, because it's not in the middle group, because the middle group is like halfway. So it's this class here. At the median, actually this class here, okay, because it's in the 25th position, which again corresponds to the when you add the frequencies together, where 25 would lie in that cumulative frequency. So it's he's wrong about the class. So actually, that's your reasoning, I guess. So and also as an exam tip, 90% of the time, these sort of is he or she correct questions 90% of the time they're going to be wrong. Okay, so kind of assume it's wrong. That might help you then work out, but they might be right, but very rarely. Anyway, so it's wrong here because Seizure is wrong as the median class is uh is between 25, wasn't it? No, sorry, yeah, between 25 T and 30. Uh, not the middle class, okay, or the middle group. And that's your reason because you got the he's automatically wrong because the middle group is not the median group. But even then, he's not saying the estimate for the median temperature. He's saying the median temperature is 22.5. Say if it was, for example, say if he instead said it was 27.5, which would be then in the middle of this. You can't. The estimate would maybe be that, perhaps. But they wouldn't categorically. You can't just conclude it's 27.5. The best we can do, at least for GCSE, is the estimate will be. You can't go any further than estimating the class it's in because, like I said, it's grouped. So it could be all over the place. For example, all the data between 25 and 30, because there's 21 of them, all 21 one of them can be like 25.1, you know. So that saying the median is exactly in the middle isn't exactly right. You maybe could estimate it if you want, but again, you wouldn't really do that. But you can't just. But it's not saying the estimate for the median. is 22.5. It's saying it's actually 22.5, which is wrong because you have to estimate. Because it's grouped, because of that, because it's so much you don't know the exact numbers, you can't get the exact median. Okay, so he would be wrong for that as well, even if that was right. But because he got the median wrong, the class, well, then he's wrong for that. But yeah, so with this sort of question, just check the median, right? And actually, when we did the median, he was wrong. Um, so yeah, move on to question 4 now. Now, I believe I think there will either be a scatter graph question or a frequency polygon. They're both not too bad, I don't think. But I think one or two of them are. So you need to check your graph skills. So here I did a scatter graph question. If I have to, if I was in another session tomorrow, and I'll probably pick up a frequency polygon instead. But anyway, so let's deal with the present. Okay, so it's a scatter graph question, and it says the scatter graph shows information about marks of a group of students in a science and a maths test. Okay, and then it said Jamie got a mark of 34 in the science test. Using the scatter graph, find an estimate for his mark in the maths test. So here, notice we've got the maths test, and this should be the science test. I don't know why they've not labelled it. But this would be the science test as a result. So so how would you use the graph to find if we give a one number? How can we get the other? Okay. Well, it's going to be we need a line, right, to connect them, and that's what we're going to do. It's a line of best fit. So the line of best fit. Am I going to get a ruler out for this? Yeah, go on. There it is. Okay, so let's move it over here. So the line of best fit. Let me get this ruler. Oh, see, this is why I don't use the ruler. It messes my whole document. Oh my god! Oh, for God's sake! Oh God! Oh, okay, you know what? I'm sacking it. Since what I can't. I'm too new to this. Okay, now I need to zoom in. Oh my god! Go back to 100. Now we're at the start again. Okay. Okay, so I'm just going to freehand it, but use a ruler. And when you use a ruler, you need to essentially make sure that the line, half of it, roughly half of the points, are above the line, and half of them are below. Okay. And it's going to be a line of best fit. Okay. Don't do curves or anything like that. Don't try connect points either to make a line. You just need to do a rough line that goes through about half the points. So I'd probably say that would be a. Oh, that's not too bad actually. A line. I did that freehand. A line of best fit. So about roughly, just about half. But they give you a lot of leeway anyway. And so once we've done this line of best fit that goes in the middle of the points really, then we can use it like a normal line graph, right? So we have the mark is 34 for the science test. So we need to work out where 34 is on this axis. Well, each box is clearly going to be 1. So 34 is going to be here. Okay. So therefore, then if we draw a line up, it's going to be there. So then when it crosses the line, our line of best fit, we're going to need to read off it. So it's going to look, uh, it's going to be about in the middle, isn't it? There. Again, make sure you use a ruler for all of this, right, to be accurate. Okay, so it's going to be there. So it's, oh God, it's way too squiggly. Let's try to do it a bit better. Oh no, no, oh, oh God, I have to do it all again now. The line. There you go, something like that again. Line of best fit. So it's going to be God about there. So it's going to be nice. There we go. Did it for me that time. So it's going to be if you read off the graph here, where this line that we draw crosses the line of best fit. If you then read off to then hit the math axis on this side, where does it cross here? Well, it's about 38.5. Okay. So it's between 38 and 39. But like I said, they're not going to be too pedantic. And so really that would be the math test mark, right? 38.5. And that's really all you need to do with these sort of questions. And they're very typical with scatter graphs. You need to draw a line of best fit to then estimate results, right? So if you're given a number on one part of on one side, you then need to connect. You then need to read off the line graph, right? The line of best fit to then go to the other side here to get off the estimated value. Okay. So then the estimated mark will be 38. The maths mark will be 38.5 that we got. Okay. And actually, what I'm going to do is actually then check the mark scheme, because you are getting a lot of a range of values for this. And by the way, while we're talking about this, the mark scheme, you can also access where every question came from because I'll tell you where it comes from, the paper it's from. So if you ever stuck a particular question, really stuck, or just really want to see it for some whatever reason, you can access the paper and then find the question there. Okay. So let me check this. I want to see exactly what the range of values are for it. Yeah, 38.5 is fine. The range is actually pretty decent. It's between 35 to 42, seven away. So it's between, you could have between here and here. Again, we're nearly in the middle actually, so we didn't do too bad of a job. Um, but yeah, so that's how you'd tackle questions like that. With scatter graphs, especially, you're pretty much always going to need to be thinking about doing the line of best fit, which again will pass me about in the middle of the points, right? In between. Okay, question 5. Um, okay, so hopefully you recognise it's going to be to do with angles and parallel lines, so your corresponding, your alternate, your cointerior angles and stuff like that. This doesn't come up every year, surprisingly, but it could come up right. It is one of the like topics remaining. They could very easily ask it. So let's have a look. So we are given two straight lines, ACF and AD. Just basically, F it's in the graph, right? I don't even need to read off what's going on. We need to show that ACD is isosceles, right? So there's this triangle here. We need to show it's isosceles. There's two ways of doing that. Either two sides have to be equal, so say here and here, or two angles are the same. Now here we're not given anything about lengths. It's obviously we're obviously gonna have to do some of the angles then. We're gonna need to consider what all the angles in the triangle are. Okay, that's what we're gonna need to do. But we can't do anything just yet. Because we're not given any angles directly in the triangle, but we are given some other angles, and that's where we're going to have to use our knowledge, right? Okay, so with this sort of question and with Stark theorem and stuff like that, try and work with what you're given and see what you can do out from that, and then work your way from there. So the first thing that strikes to me actually is this angle here, because we're given 110, and these two angles are on the line. But we know what an angle on the line has to add up to, 180. So that means angle, which you can write as this little sign here, angle, and that would be ADC. So, by the way, if you're struggling with having to label an angle, you go in alphabetical order, so A, D, A, C, D. However, the middle angle always has to be the letter at the angles, D here, always has to be in the middle. Okay. So you do it in alphabetical order, but make sure the actual angle, the letter at the angle, is in the middle. Okay. Anyway, so angle ADC, well, that's going to be 180 then, minus 110. Because obviously these two angles on the line, hopefully you can see that it's on the line. So that's then going to be 70, right? And it says give a reason for each stage of your working. So this is going to be because angles on a line add up to 180. Okay, so that's the first thing I'll spot. Great, so I've got one angle already in the triangle. I can't do anything else really in the triangle. So we're gonna have to consider this angle then, right? And it looks like a parallel lines question, right? Because we're given two parallel lines, and we're also given the line between them here. So we're going to need to use some sort of corresponding or co-interior or something like that. Well, we do have a co-interior angle here, and that would be 180 minus 125, right? And then that would be 1, 2, 3, 4, 5, 55, right? And then what you could say then is this would also be 55 because then they're vertically opposite. So co-interior, remember it looks like this. So we have two parallel lines on the top and bottom, and then obviously a line that connects them. Then an angle here, and then the angle up here, so make a C shape. Hopefully, it looks like a backwards C. They add up to 180. Okay, so here 125. So then this has to be 55 for both to add up to 180. So therefore, angle BCF is going to be 180 minus 125, which would be 55. Okay, and that's going to be uh, because the angles are co-interior. Okay. I think there's another. I can't remember. There's another word you could use for co-interior, depending on how you've been taught or how you looked it up. Um. I can't think of it now. But it's co-interior. That's the word, and I use anyway. So that's going to be 55, and then therefore this angle, the triangle. Right now we've got second angle. That's also going to be 55. So angle ACD now is going to be 55 as well. 50 degrees, and that's because the angles are vertically opposite. Okay, so what that means is vertically opposite is when you got a lines that also almost make an X shape. So two lines that cross each other like this, right? Any two lines doesn't have to be parallel. Well, they can't be parallel because they intersect each other. Any two lines whatsoever. What the opposite angles are here and here. They're going to be equal. So notice here, these two angles are vertically opposite. So we have this little cross here, here and here. So therefore, these two opposite each other are going to be 55. Likewise, this angle here and this angle here will also be equal. So that's vertically opposite. So that's going to be 55 as well. But actually, we know two angles in a triangle. We can work out the other one, can't we? Because we know what angles in the triangle add up to. So actually, then the last angle, which is CAD, that's going to be 180 minus the other two angles, right? So 55 minus 70. And that's going to be, if you put it in your calculator, 55. And that's great. because that's what isosceles means, right? We have to have two equal angles, and now we do. And the reason for that, by the way, is going to be because angles in a triangle sum to 180. Okay, and that's it. So therefore, exactly two angles. The wording is quite important here. I'll go over it in a minute. But exactly two angles in the triangle are equal. Therefore, the triangle must be isosceles. Okay. Now I said exactly two angles the same. Because if you said two angles the same, I mean, they wouldn't. They'd be fine with that. I think I did check the marks. I think that they'd be fine with that. They're not going to be too bit down to. But when you say two angles, you kind of perhaps saying it could be two or three angles the same. But we know if three angles are the same, then it's going to be an equilateral triangle. That's not what we're proving here. We need to show it's isosceles. So isosceles is when exactly two angles, all two sides, are the same, and no more or no less. Okay. So just be a bit careful of that. But that as long as the general idea that two angles are the same, it's you know only two angles, then you're fine. So I guess that's 55 as well, and there we're done. Cool. And yeah, so that's the whole idea, right? If we want to show a triangle isosceles, so we need to consider the angles, and that's kind of what I did. So then I went from there, right, to then deduce any the angles I could from the two given angles, and then I went from there. So I got this angle first, then I spotted that this angle is co-interior to this, and this is vertically opposite to this, and then it's a triangle, so we got the last angle. Alternatively, what you could have said was well, here, exactly, this is angle 125. This is going to be corresponding to this one, which will also be 125. And therefore, this angle here in the triangle is going to be, again, it's on the line, right? Here, they're on the line. So that would be 180 minus 125, which would still get you 55. But it'll be for different reasons, okay? So corresponding angle for 125, and then it would be the fact that on a straight line or like a line, so therefore it would add up to 180. And yeah, and then you go from there. The rest of it should be the same. And so in general, you do need to be aware of corresponding angles, which in this case would look like this. Oh. So we have two parallel lines here. And then we have a line that goes through both of them like this. Then this angle here would correspond to this, exactly like in this diagram here. And they correspond. And it looks like because basically you can kind of see this because they're in the same position, right? So it's kind of, so I guess you can kind of geometrically visualize that they're going to be the same. But that's corresponding and they make a sort of F shape. Okay, so if I said, for example, if we had a parallel line here and here, this angle would then be same as this one, and you can see it makes an F shape, okay? It's not a C shape because this would be a co-interior, this would be the C shape, but because it has to go up here, this angle, it extends to an F. And actually then co-interior, next one, will have to make a C shape like this, and they're in the same sort of section, okay, I'd like to call it. And that would be, and then they'd have to add up to 100, they won't be the same, they'll have to add up to 180. Then you've got alternate angles, so that would make a Z shape. So this angle then would be equal to this one. There would be alternate. Okay. Oh no, sorry, this one. Um, it would make a Z shape, right? So it would be this, right? For alternate angles. and you can see that because it makes a Z shape. So you have here, uh, here. So you go here, then here, and then here. Right? You can see we made like a Z shape. Yes. And so that's your alternate angle, and they will also be equal. Okay, so corresponding equal co-interior add up to 180. Z shape like this, they're here, they equal the alternate. And the last one, which isn't to do with parallel lines, it'll be is when two general lines cross, then the opposite angles will also be the same, and they are vertically opposite. Okay, so those are all the angles on lines you need to know about. Okay, cool. Hopefully that made sense. Move on to the next question. Okay, okay, so now it gets said, Martin used his calculator to work out the number of a value of a number p. He wrote down the first two digits of the answer on his calculator. He wrote down 1.2, completely error interval. So again, error interval is saying like the bound, so like how the range of the possible range of value of p can be, right? So, what you need to realize with this one, there's two types of error intervals. The first one is rounding. So, if they say he rounded a number to one decimal place or significant figure or whatever, that's rounding. So, you have to do a slightly different procedure where you have to look at where the number it rounds up to and down to. And I did loads of examples like that already in the previous streams. But this one's not really rounding. Because really what's going on is, think about a calculator. Calculators are round. It just gives the numbers as it is, like 2.4617928. You know what I mean? There's no so if we're just doing the first two digits, for example, and then we slash the third one and anything after, we're not rounding, we're just simply slashing the number off it. This is called truncation, when we literally just take the 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 next the digits afterwards off. We don't do any rounding. We just literally sack off and get rid of the digits. And that's truncation. Um, because basically we just saying we ignore all the other digits, right? We're not rounding. We're just literally ignoring it and just getting rid of them. Okay. So that's truncation, and what that means is then, well, the first number, if it's 1.1 anything, say like 1.987, it would still be 1.1, the first two digits, so we don't care. So the first digit's actually just going to be 1.2. That's the lowest number he can be. So it'd be like 1.2000000, so on. That would be the smallest number, right? So the first two digits 1.2. Well, then what about the upper number then? Well, 1.30000. Well, that's going to be the number when it's 1.3, not 1.2. So then we want the number before it. Well, the number before it's then going to be like 1.2999, so on. And it's going to have 1.2. So that's to the first two digits. So that's cool. That's what we want. But then we can't, this 999 bit goes on forever. We can't write a number. So then what we say is 1.3 is the upper limit here. So the next number, which is 1.3. But we say any number less than 1.3 is P, okay? So this number itself cannot be P, but then any numbers before it are. And so that means basically it resolves the sort of problem of an infinite amount of nines, okay? And that's sort of the strategy with this sort of truncation question, okay? Um, and hopefully you can spot it's truncation and not a rounding question, okay? Because we simply only consider, it literally says only consider the first two digits of a number. So we're not rounding, we're just literally again cutting off all the other digits. So it'd be 1.2, and then think about all the numbers that are 1.2 to the first two digits, and then anything else we have afterwards, okay, to still give 1.2. Hopefully it made sense. I feel like error intervals can be a bit tricky to, I don't know as well, but hopefully it made some sort of sense. If instead we had a rounding, say for example, P rounded to 1.2 to the nearest decimal place, that's not truncation, okay? Because 1.2 we then consider in the next digit. To then a number that rounds up to 1.2. We're not saying it is 1.2. We're saying a number that will round up to 1 or down to 1.2, vice versa. So we want a number that rounds 1.2 rather than just a number that is 1.2. Hopefully that it's the distinction there. How we would then approach it as well. Then 1.2 to the nearest decimal place. What would be the next number? So this is 1.20, if you will. Then the next number would be 1.21, and the number before it would be 1.19. Then we'd want the in between, so 1.205. No, sorry, no, that would be to the nearest two decimal place, wouldn't it? The nearest decimal, then it'd be 1.3 and then 1.1. Okay, so the first decimal, I was doing two decimal places. So one decimal place, right, 1.2, then the next one, the 2 would go to a 3 and then backwards to 1.1. Then in between would be 1.25, and here it'd be 1.15. And those are your bounds in that case, right? 1.15 to P to 1.25. That's your upper limit and that's your lower limit. Okay, so hopefully you notice the distinction in between this question, which is the truncation, where we just slice off all the other digits. We don't care about the other digits, and this one with rounding, where we want a number that rounds to 1.2. Okay, so it's going to be this instead. Uh, but yeah, that's that question. Okay, then question 7. Let's move on then. So we said on Monday, 12 people took 5 hours to clean a number of cars. Then it says on Tuesday, 15 people cleaned the same number of cars. So what's happened is originally 12 people cleaned a car, then 15. So, and then we're given this, right? Assume all the people worked at the same rate. Um, Work out how many hours it took for 15 people to do it. Okay, so for this question, again, it's very typical sort of question. It's sort of like proportions or rates question. You basically need to, well, the same. The, what you need to realise is essentially there is it will always be the same amount of. You need to work out the time it takes to do the activity, so to clean the car. So we know 12 people took 5 hours. So now how much would it be in total then? So that'd be 12 times 5, right? So then that would be 60 hours. Okay. Put that in the calculator if you want to. And that'd be the time total to clean. Okay. Alternatively, you could visualize as saying one worker takes 60 hours. Okay. Um, okay, because think about it, right? If you're doing the same amount of work, but now there's less people doing it, it's it's going to take longer for the worker, right? So in this case, it makes sense to do this sort of thing, right? What you do not do is say, well, 12 people equals 5 hours, and then like with sort of like ratio question, divide by 12 to say one person takes 5 divided by 12 hours, which is what, like 0.4 something. Let me have a look. Yeah, 0.416 hours. So obviously, what he's saying there then is one person takes less time when it's only one person doing all the work. So you got to remember that it takes the same amount of time in both. If there's one worker or 12 workers, but then if there's less workers and you got to do the same amount of work, they're going to have to work for longer, right? So you got to visualize it in that sort of way. Do not do it this approach with ratios. That's not what's going on here. Okay. Um, Okay, so we know that 60 hours is the time we need to have, but now we have 15 workers and they work at the same rate. So we need to just share 60 hours between 15. So it's going to be 60 divided by 15. So for each worker then, so all 15, they would do it in 4 hours, right? Because then 60 divided by 15 is 4. and that'd be your answer. And so it might look very simple, but don't fall into the trap of like, say one workout would be like take like 0.4 hours. It's the opposite way around, okay? But yeah, this sort of question is very common. Make sure you have seen it and practice a question like this, as simple as you may think it is. Um, Understand what's going on here. Okay, so I'm saying again, like if we haven't some work, we have a fixed amount of time needs to be taken to do the work, right? So in this case, we said we've worked out by 12 hours, 12 people do 5 hours of work. So then the total amount of hours of work is going to be 60 hours, right? So the 60 hours needs to be done. So that's saying one worker. If there was only one worker, that would mean that has to do all 60. But then if we have 15, we can share it between 15 people. So then each of them only do 4. Uh, and that's where the answer comes from. Okay, hopefully it made sense. And then it says the assumption is wrong. Again, this is fairly common as well for this sort of question. This is an assumption you are assuming with these sort of questions. Then it's saying if it's wrong, what would happen to your answer? Well, actually, there are two ways. Either people could work faster. Um, so I could say uh, either some people would work at a faster rate, so work faster. So the time would decrease, right? Or it could go the other way. Some people could work slower, okay? Slower than others, okay? So some people would work slower. So the time taken to clean the car would increase. So the time would increase. And that's essentially what you need to say, okay? Okay, cool. Um, there we go. Okay, we're on question 8 now. And again, they seem to love to ask these sort of pressure questions every year as well. I haven't come up yet, believe from what I've seen anyway. So, what paper 3 could do, but let's do it now. So, we are given a box in the shape of a cuboid is placed on a horizontal floor. The box exerts a force of 180 newtons on the floor. The box exerts a pressure of 187.5. So I'm going to just highlight the key bits, right? Pressure, force 180. The face is in contact with the floor. The face in contact with the floor is a rectangle of length 1.2 meters and a width of x. Find the value of x. Okay. So first of all, work out what we're missing here. So we're given a force and a pressure. Therefore, we're probably going to need to work out the area. So immediately, before thinking of anything else, I'm just going to then say, well, if pressure is force over area, and we know what the pressure and the force is, we can use that to work out the area. Say if we don't need it, but you know what, we probably only spent like 10 seconds on it, right? So not much time is lost. But usually, like I keep saying, they give you every bit of information for a reason. Every number they give you is there, that every information you're going to need. And also, then, because of that, if you're not using a particular number in a question, you probably skipped something or forgot something, and therefore your working might be wrong. But they give you every number and every bit of information for a reason for you to use, okay? So because we're given force and pressure, we're probably going to need the area. Anyway, so we're going to rearrange to get area in the subject. Where we're going to times both sides by the area to then get area and rearrange it. So area is instead force over pressure, okay? Because then area times pressure be force, then divide by the pressure, just get area, okay? Okay, so that's the area, but then we know the force is 180, right? Newtons, and the pressure is 187.5. And so you put that into the calculator, you're going to get 180 divided by 187.5 It's going to be 0.96. That will be, what's the units? Meters squared, right? Because it's an area. Okay, so that's an area, but that's not giving us what x is. How are we going to use this then? So then let's have a look at this. The face in contact the floor is a rectangle with a length 1.2 and a width of x. So it's telling us it's a cuboid. So it's going to look like this, right? Oh. So it's going to look like that, right? So it's going to have a rectangular side here. And what is said is the face and the contact, the face. So the face is referring to the side, right? So that's a face. This is a face. This is a face. And obviously the back and the sides and the bottom of it is also faces. Okay. Let me get rid of these dashes here. Um, So those are the faces, right? So if like think about surface area, right? The area of each face. That's what that's saying. The face is in contact with the floor. The face that is in contact with the floor is a rectangle of length. So it's going to be this side, right? Of length 1.2. Um, so this side. So think about this side then. So it's going to be this side I highlighted here. And basically, with these sort of pressure questions, you only usually they give you like a 3D shape, but the area is going to be the shape or the face, sorry, or the surface that is in contact, right? So you're only going to want to consider this rectangle side here. And we are given that its length is 1.2 and a width is x, okay? So that's the but then we know what the area is. We just worked it out. It's 0.96. So 0.96 is the area of this, right? But we know what the area is. It's going to be length times the width. So 0.96, where the length is 1.2 and the width is x, okay? So then to get x, well, we're going to divide both sides by 0.1.2, right? To get rid of, to get x on its own. So therefore, x is going to be 0.96 over 1.2, and then you put that into the calculator. 0.96 divided by 1.2, it's going to get you 0.8, okay? And that'll be in meters, and that's your value of x, okay? Cool. Hopefully it made sense. Um, so really, I think the big question usually with this sort of pressure question, you need to work out what area to consider. For example, I did see this one on a past paper. So if we had a cylinder, if we could draw a cylinder, look like this, right? If our force is this way, so it's working on the circle at the bottom. The area we're considering here is this circle on the bottom, okay? Um, and obviously that'd be pi r squared. So you need to work out where the force is acting. And here, the force is acting on this side here. So we consider the area of this side, which is the rectangle. Okay, hopefully that made sense. We'll move on. Okay, question 9, parallel perpendicular lines. Now, I believe there was a question on line intersections and stuff like that. I don't think it's to do with parallel and perpendicular. They gave it a gradient, but it wasn't parallel or perpendicular. So there might be a specific question for parallel or perpendicular lines. So let's have a look at this one then. So we are given the equation of 5 straight lines. We're given 2 of them are perpendicular. Write down the 2 perpendicular lines. Okay. So with this, you need to remember that a perpendicular line means what? Well, it's going to mean that their gradients are negative reciprocals to each other. Okay. So for example, if we had a gradient of 2, the negative reciprocal, well, the reciprocal of a half, and negate it minus a half. Doesn't matter what order you do it in, it's fine, whatever. You could also do -2 and then do the reciprocal, which would then be -1/2, and that'd be the same thing. So that's what we need to do. We need to check which two numbers are the gradients of negative reciprocals, but not all of them are in the same sort of format. So remember, our format's going to be y is mx plus c, and m is going to be our gradient here, which we're going to be interested in. So we need to rearrange all the lines into this sort of form here. So line A, well, y plus 3x is 4. So then y is going to be subtract 3x. Uh, subtract 3x, so it's y is minus 3x, add 4. So the grade is minus 3. What about line B? Well, 2y is x plus 1. That means y you divide by 2 to get a half x, add a half, okay? So that's a grade of a half. They're not perpendicular, sorry. Line C, so I'm going to say that's line A, that's line B. Then for line C, y plus 2x is minus 3. No, 3, sorry. So that means y would be minus 2x, add 3 to move the 2x on the other side. So y is this. And then for line D, well, y is already 4x minus 2. So that's telling you the gradient is 4 for line D. There, hopefully you can see. And then for line E, let's see. And then y is 4x minus 2. That's line D. And then for line E, well, 2y is 2x minus 1. So if I divide by 2 and then just get y is x minus a half, and that's E. Okay, so I have so I have all the gradients now. I can easily see. So I have minus 3, a half, minus 2, 4, and 1. So I need to see the ones that are negative reciprocals. Well, I think the easiest way to swap which ones are reciprocals, I guess. Minus 3, well, the reciprocal would be like a third, right? None of these are a third. But then a half, well, the reciprocal will be 2, and then minus it would be minus 2. Well, actually, isn't that gradient here for C? So therefore, B and C are perpendicular. Well, you could check. If you times the two gradients together, half times minus 2 will get you minus 1. And that will always be the case if you times two perpendicular gradients together, they will always give minus 1, okay? And then that'll be B and C. Well, line D, just to confirm, D's 4x, so then the negative reciprocal will be minus a quarter. None of these are minus a quarter. And then for E, the gradient's 1 here, so 1x. So then it will just be minus 1 for the negative reciprocal. But none of these are minus 1x, okay? So therefore, this must be our answer. Okay, cool. Question 10. Again, they ask these like every year as well. These sort of questions with like compound interest, like a percentage going up every year. Let's have a look. Okay, so we're told Louise invests X amount in better investment for 3 years. That's going to be this one. Then Sadiq invests X amount, the same X amount, in County Bank for 3 years, which is going to be this one. Okay, at the end of 3 years, the value of Louise's investment is 344,605. Work at the value of Sadiq's investment. Okay, it goes back to what I said earlier. Every information, every number is given for a reason. So we have to use this bit here, probably. But we need to work out Sadiq's investment. So, but we don't know the original number, so that it's X. Right, so we're going to need to work that out first. So I think we're going to use this. So Louise is better investments, okay? So it's going to go through here. And what better investments does is a 2.5% interest per year. Annum means year, okay? And so we're going to go from there. So if we have X amount, okay, that's our starting that number, right? That she invests in. This compound interest of 2.5 per year, well, that's saying every year we add 2.5% of that number, right, on top. But this is going to be multiplier, right? So you really should be comfortable with multipliers. That make your life very easy for these sort of percentage change questions. So a multiplier, well, we're going to represent a 2.5% increase. Okay, so we added 2.5% onto it. So it's going to be a 2.5% increase. So that's going to be 1.025. Okay, you can visualize this, well, not visualize it, sorry. You can see this is a bit stuck because it's essentially saying 100%, and then you add on your 2.5%. That should increase percentage. That'll be 102.5. But then to get a percentage to a decimal, you divide by 100, which obviously then means you move the decimal point two sides here to get 1.025. That is your multiplier, which means if you times anything by that number, this number here, you get 2.5% increase, okay? And that's what we want. So x times is 1.025. That's going to get you then your amount after 1 year. But then we're going to be times it by another 1.025 in the second year. And then we're going to do the same in the third year. After that, we're going to times another 1.025 in the third year as well. But then if we times them by the same number 3 times, isn't that just going to be 1.025 cubed? And that will represent then the compound interest after 3 years, okay? And we are told it's this number here, 344,605, okay? And so therefore we can solve for this x, right? So let's work out this bit first. It's 1.025 cubed. So this is saying x times 1.025 cubed. It's going to be not a nice number, okay? So what I'm going to say instead is, well, x times 1. Let's make it a bit clearer. X times 1.025 cubed, there we go, is 344,605. Then I'm just going to divide by this, 1.025 cubed. So x is going to be 344,605 over 1.025 cubed. Why didn't it evaluate it first? Because you get quite a nasty number in your calculator. But if you do that then, so if you do 1.025 cubed, then you do 344,605 divided by your answer, you get this number here, 320,000. Exactly. Right, there's no decimal point there. Okay, so that's your value of x. Cool. So we found x then. Now, can we not apply this x then to the compound interest here to get the amount of after this county bank after 3 years? Right? So now we know what x is. Well, Sadiq invested in county bank. So we're going to need to look at these percentages here. So we want 3 years. So let's have a look. So we have a starting investment, so starting number of 320,000. Then what we're going to times it by. So in the first 2 years, it's a 2% 2% per annum. So we're adding 2% on every year. So again, our multiplier is going to be 1.02, and then that'll be end of first year. But then after second year, we add another 2% on. So we times by 1.02 again. That's just going to be 1.02 squared. Okay. And that'd get you, and that'd be your second year, right? And so if you put that into the calculator, 320,000 times 1.02 squared, you get 332,928. Okay, but that's the second year, right? Because we applied 2% every year, so it did it twice, so that's 2 years. But then that's only for the first 2 years. We want the next year as well, which will then take us to third year. But then it says 3.5% after every year after. So then we're going to have to we're going to add on 3.5% this time. Well, how are we going to represent 3.5%? Well, it's going to be 1.035. Again, if you're struggling, do 100 add 3.5. That's going to be 103.5. Then divide by 100 to get rid of the percentage. Yeah, so that's both in percentages. To then get 1.035, and that'd be your multiplier. Okay. Okay. So then we do that into the calculator. So times what we just got by then 1.035, and that'll be this number here at 344,580.48. And obviously that's going to then be in pounds, right? And that's your answer. That is how much then if Sadiq invests at the end of 3 years, right? That's what he gets back. And that's with County Bank. Okay. So remember he invested in County Bank. So then we need to go through this. Okay. Okay, so that's fairly typical, right? So that's both reverse percentages. So when we are given the end amount, we then need to reverse percentages to get the original. The best way to do that is just let the original value be x, and then you go forward. So then you do the normal percentage, and then you get then you solve x at the end, like we just did. Okay, and then that's compound interest. I predict there will be a question like this, right? They love to combine compound interest with reverse percentages. So you need to make the both topics that haven't come up yet, at least in their own in a proper way, anyway. Um, so this you will definitely get a question like this in paper 3. So make sure again you're prepared for that. Hopefully it made sense. Because it is I think this is going to be an important question. So yeah. Um, I would say, what's the next question? Yes, so just a comment now. Anyone on foundation, we are no longer on. Well, I think question 8 would have been the final foundation question. So obviously, for every paper, there's a cross section between high and foundation. There's a crossover in questions. So the paper at the end of foundation would be at the start of higher usually. This is the cut-off point, I'd say, I think. And even after this, so when we did perpendicular lines and the compound interest stuff, that's higher tier stuff. I believe anyway. Um, and so this will be higher only at this point. So this is like grade 6 stuff now. Um, but yeah, just to let people know. Anyway, so we're on question 11 now. So I spot this is a cumulative frequency question. Again, this will come up as well. I reckon it comes up every year as well. And it hasn't come up yet, so uh, make sure you know how to do questions like this. I would say, by the way, as well, always before I go on, talking about where you can get the topic questions. So again, you know what are the topics that I like to come up now in paper 3. If you do want to practice specifically those topics or a particular topic you're weak at, I do recommend Maths Genie and then go to resources, I think. No, sorry, GCSE revision. You can go on resources as well. But GCSE revision, and that gives you all the topics singular, every single topic one by one, separated by grade as well. And every topic will have a question pack. So you can practice all the questions on that topic. That's how I learned. How I got a 9. I wouldn't have got a 9 without Maths Genie. When I did my GCSEs. Um, really good website in my opinion. But obviously, whatever works for you. Anyway, we're given a group to table again, kind of like what we had earlier, but we're looking at the cumulative frequency instead of the mean and stuff like that. So then part A says to complete the cumulative frequency table. So not too uncommon. So you need to they give you the frequency of each amount. So then the cumulative is when it basically adds up together, right? So we start off with 5. Um, and then, well, you then 30, but then 30 add the 5. It's going to be 35. Then the next one's going to be 20. So then 35 add the 20 is going to be 55. Then you have the 55 add the 15, the next one. So that's going to be 70. Then you're going to have the 70 with the 8. That's going to be 78. And then you're going to have the 8 with 78 with the last 2. And that'd be 80. Okay, then it says for part B, draw cumulative frequency graph. They can get you to sketch it. It could come up as well. Good thing to practice. And so the way you sketch it, or draw it, sorry, is to realise actually you need when you you're plotting the time. So the time is going to be. Let me go up here. Is going to be this section here against the cumulative frequency, which is drawn here. And you know you added it right, by the way. If you get it's 80 at the end, so you get the total. So here total's 80. If you get the total 80, then you should have probably done it right. Okay, it's a good little instant way to check your answer. Anyway, so we need to plot the time against cumulative frequency. Well, we have a definite number here for the frequency. That's good, but this is again all grouped. There's not one singular number. It's a range. So how are we going to again plot that on here? Well, last time we did the midpoint, which represents the average value, I guess. But instead, what we're going to do now is consider the end point because this 120, we need to finish on 120, right? Here, which would be here. But then it finishes at 80. So 120, which is the last time value we can get, is going to mark the end of the frequency. So it's going to be here. I hope you can see that. I'm plotting 120, 80. And then we go from there, right? So then we have to consider all the other endpoints as well. So 100, then it's going to be 78. And again, you need to work out what each box represents. So one box is going to be 2, right? Because between 80 and 70, for example, here, there's 5 boxes in between, but there's 10 in between 80 and 70. So each box is going to be worth 2, which means 78 is going to be for 100 here, right? And actually, I'm going to zoom. Nah, I'll zoom in after to see, but I need to see what the numbers have got up here. But hopefully you can see that it's going to be 78. And then for the next one, so 80 now, that's going to be 70. So then 70 is going to be here. And then for 60 here, it's going to be 55. So that's going to be in the middle here, right? In the middle of the two boxes. And then we have 40. That's going to be the 35. She's going to be again here. And then we're going to have 20, which is going to be 5. So 20 here would then be, that'll be 5, right? Okay, and I'll zoom in so you can see the points as well. But that's essentially what we've got here, right? So hopefully then you can see clearer what the grid is, right? So there's 5 squares here, but then here it's 10. So that means each square is going to be 5 here. So each square is going to represent 2 on the frequency. And then I'll plot the points here. So here this will be 55 here. That's going to be 70. This is going to be 78. And that's going to be 80 up there. That's 55. This is going to be 35. So in between the two boxes here and here, it's going to be 35. And then here is going to be 5. Okay. Again, in between this box here and this box here. Okay, and that's how we plotted it. Okay, so we plotted all the points. That's what you need to do. Plot all the end points. So again, start with the end. So at the final frequency, right, the full 880, that has to go to the end, right? So the end is 120. Remember here. So the final number in the T is 120. So we start here and then we go to the other endpoints and go from there. Obviously, it doesn't matter what order it is, but I think that makes the most sense for me anyway. Anyway, so the key crucial thing again to reiterate, you need to put the endpoints of the groups against the frequency. Once you've done that, but then you need to connect them with a curve, okay? That goes through all the points roughly, and I hope I can draw it properly. So, free hands in it. it's going to look like this, right? Something like that, okay? A curve that goes through all the points. You do not draw it line by line to each point. So say like here, and then you do it here, and then here, and here. That's a frequency polygon, okay? Don't get confused. You draw a single smooth curve between the points. Okay, that's part B. Then it says part C, use your graph to find an estimate for the percentage of the workers who will take more than 90 minutes to get ready. Okay, so again, it's like with scatter graphs, like with a lot of graphs, it's very common to then use your graph to work or estimate something out. So here, we want to find the workers who take more than 90 minutes. So we're going to have to read off the graph. So we want T is 90. Then again, like the scatter graph, we're going to need to read off our graph by connecting it to the curve. So if we draw then a line that then reaches the curve, if we draw a better line than that, we're going to keep drawing up from 90 up to here, and then it's going to roughly go up there, right? It's going to be this line here, and then we read that off, and draw this line all the way. Okay, that's a bit rubbish. Let's continue this line then. There we go, nice. Yeah, okay. So that's what I've done. So where it intersects, then I've drawn a line to then get the frequency. The frequency here is about 76. Okay. So then 76. So 76 is the cumulative frequency. Well, then that means that between that's saying then if that's 76, then that's saying there are there are 76 workers who take less than 90. So anyone who takes more than 90 is going to be up here, right? So it's going to be between 76 to 80. Okay, so anything above 90, it's going to be 4 workers then, right? So that means workers who take more than 90 mins is 4 workers, right? So there's 4 workers. Because again, the cumulative frequency is 76, which means between 0 and 90 for your time here, right? It's going to take between 0 and 76. So that means over 90 is going to be here, right? So it's going to be this gap between 76 and 80, our total. So that means 4 workers are above 90. Hopefully you can visualize that. Cool. So then I'm going to zoom out now. So really, we want the total, the percentage is going to be then, if I zoom out, hang on. The percentage is going to be 4 out of 80, right? Because the total is 80. And that's the percentage of all the workers, right? So out of the total workers, how many are more than 90? Well, we saw that was 4 workers. So 4 out of 80 times 100 to get percentage is going to be 5%. Okay. And there we are. Okay, again, there should be some leeway here because of the fact, obviously, you have to draw the graph. So it's going to be a bit rough, especially for me, because drawing on this laptop, oh God, it's a bit rough. Let me check the range of answers for this one. Uh, so 2019 paper 2. Was this the right paper? Oh, okay, I did the wrong one. 2019, paper 2. Uh, okay, so actually the answer was 7.5 because, again, because of the fact the graph was a bit off. Uh, so officially they got 74, not 76 by reading it off. However, they actually give you follow through as long as you state. So I said 76 here. What value you get from reading it off? If you get the right answer using that, which I did, then that should be fine as well. So they give you some leeway there as well. Okay, cool. Okay, question 12 then. Uh, and I said redacted intentionally, so I'm not giving the topic away here because that's going to be, I think, most of the battle actually. Um, but let's have a read of the question. Sammy asked 50 people which drinks they like, some tea, coffee, or milk. All 50 people like at least one of the drinks. 19 people like all three. 16 people like tea and coffee, not milk. 21 like coffee and milk. 24 like tea and milk. 21 like coffee milk, anyway. 40 people like coffee, and then one person likes only milk. And he selects one out of the 50 random. Find the probability the person likes tea. Okay, so you need to think for yourself for a second. What am I going to use here? What topic is this? Right, it says probability, but this looks like another thing I can do. A user here. And what I'm going to say is we have three categories, right, that people fall into. And we need to kind of, and they're talking about people who like a combination of them. So actually, um, um, you could potentially think maybe tree diagram because it looks kind of like a tree diagram question, but it's kind of look like this, right? Because we're only picking one. Obviously, you'd have tea, coffee, and milk, but you need how many people like coffee and stuff out the total and stuff like that. What I'm saying here, you need the people who like tea out the total amount, coffee out the total amount, and milk out the total amount, right? So something as a fraction here, a fraction. So out of 80, out of 50, sorry, out of 50, out of 50, out of 50. However, with this, you can't just work out how many like tea on their own because it's talking about people who like a combination of all of them. And when that's going on, when you have three categories like this, and you're given a bunch of information, and they're talking about people who like a combination or none, or some to cat, some to stuff, it's going to be a Venn diagram question, okay? Because we have three categories here, and again, they're talking about and Venn diagram. Remember, if we then draw three circles that overlap like this, it's gonna the overlaps are important here because the overlaps represent people who like all the combination of drinks, right? So it won't be a tree diagram because it doesn't incorporate the fact that people can pick both and stuff like that. Um, so therefore, it won't be a tree diagram. It'd be a diagram question. So the Venn diagram's going to look like this. So we have that box here. So all 50 people have to fall into this box. And then these three circles represent each type of drink. So this can be T for tea, C for coffee, and M for milk. Okay. So again, like these Venn diagrams, when you fill them in, you should start from the intersections and work your way out. So first of all, let's consider how many like all three drinks. Actually, it's 19. So when they all overlap, it's going to be here, right? 19. All three circles overlap there. Then let's look at when the two circles overlap. So let's look at tea and coffee. So it says 16 people like tea and coffee, but not milk. So that's going to be 16, right? So that's 16 people who like tea and coffee, but not milk. So it's not going to include this number because these are the people who also like milk on top of tea and coffee. Okay. Oh God, let me draw it again. There you go. So that's just going to be 16 there. Then let's have a look at milk and coffee. It says 21 people like milk, coffee, and milk. Okay. So that includes people like coffee and milk. So it's going to be here, but also it's going to be the triple overlap here because in here people like milk and coffee as well, but obviously they also like tea. So this represents distinctly the people who like coffee and milk, but not tea. So to work out that amount, well, 21 in total uh, like coffee and milk. So then 21 minus the 19 will get you 2, which should be how many just like milk and coffee, okay, and not tea, okay. That's the important thing to realise with this. But yeah, now let's do this overlap here, the tea and the milk. So we've done this overlap. We've done this overlap. Also, we did the middle overlap here. Now let's do this one. So tea and milk. How many people like tea and milk? Well, it says 24. But again, that's going to include the 19 because the 19 people like all three. So it's tea and milk and coffee. But they do like tea and milk as well. So the total is going to be 24. It's going to be 19 and this little overlap here, which only like tea and milk but not coffee. So to work out the overlap, it's going to be 24 minus 19, isn't it? And that's going to be 5. Okay, so 5 will go in here. And now then we are in a position to fill in the single circle here. So those who only like tea and coffee and milk. So when there's no overlap, that means they would only like tea and or coffee here or milk here. Okay. So, okay, so let's have a look at that. So uh uh tea, they're not giving anything about just tea. But coffee, they said 40 people like coffee alone, right? So coffee's on, but 40 people like coffee. That's going to include all the overlaps, isn't it? Because everything, because all of this, remember, is in the circle C here for coffee. So it's going to be every number here in the circle has to add up to 40. So then to work out this in here, that's going to be 40. Take away 16, take away 90, take away 2. So I'm taking away all the overlapping numbers here. Um, and that will get you 3, okay? And that'll go in here. So that represents the people who only like coffee, okay? These numbers here in the overlapping here, here, and here, they also like coffee, but they like other tea, other drinks as well. Okay, so as long as they like coffee, they'll be part of the 40 people. But we want the number who only like coffee. And hopefully you can see how we did that, okay? That is why you have to start from the middle with these Venn diagrams. Because if you start from here, well, you're going to need the people who only like tea. But that's going to be, you can't work that out without knowing how many like all three first. And then you work your way out. So you do have to start from the middle first with these sort of questions. And yeah, then it says from what about milk then? It says one person only milk. That's good. So that means one because remember, if it's in this space, then it's not overlapping the other circles. So again, that's going to mean they only like milk and not the other flavors as well, the other drinks. So that would be one there. Okay, so we've got this number here, and then a number outside, which represents people who don't like either drink. So then let's have a look at the other numbers. So we are also told all 50 people like at least one drink. That's saying the number outside has to be 0 then. Okay. Because every number, all 50 have to be in one of the circles. Okay. Because they have to like at least one drink. Remember, a number in the circle represents them liking that particular drink. So tea, coffee, and milk. Okay. And then, we just need this missing number in here for the people who only like tea. Well, we know the total, don't we? We know in total there has to be 50, and every number has to add up to 50. So the 0, obviously that's just 0, then add the 16. Let's do it here. 16, add the 3, add the 19, add the 5, add the 2, add the 1. What's that going to get you? That's going to get you 46. Okay. And so, therefore, to get 50, you're going to do 50, take away 46 is 4. So the remaining number we have to fill in is 4. Okay. And so by elimination, in that sense, T would, then people who only like T in this number here is going to be 4. Okay. Because every number in the box, so the 0, and then all the numbers in the circles have to add up to 50, the total, right? Um, and so therefore you can work out the missing number by subtracting 50 by everything else. Okay, that is a fairly complicated Venn diagram question, but if you do practice it, and hopefully the logic of how I explained it made some sort of sense there, um, you can use it to work out all the numbers. Now we can use this to work out the probability. So probability the person likes T, well that's going to be, well, in total there are 50, right? So then how many like T? Well, it's going to be every number in the T circle. So it's going to be the 4, but then the 5, the 19 and the 16. So 4 add 16, add 19, add 5. That's going to be 44, okay? So that means the probability is going to be 44 over 50. Okay. Um, And so again, to just reiterate that again, so this represents the people who only like tea, but these numbers also are people who like tea, the three numbers here, because 16, well, they like tea and coffee, but they like tea, you know. The 19 represents they like all three drinks, but that means they have to like tea as well, because it falls inside this circle for tea. Okay, the 19, the 16, and the 5, although it looks a bit ugly here. 16 and the 5 here, but they like tea and milk because it falls in milk, but they like tea as well because it falls inside the circle. Okay, so every number in this circle for tea is adds up to 44, and that's your probability that they like tea. Okay, yeah, so the key thing is to work out, that is a Venn diagram question. If you perhaps said, like the probability tree, you would have to work out that it's 44 in total, but it's very difficult to see that with a tree diagram. Well, you couldn't really do it with a tree diagram actually, because of the fact you have to consider all the intersections and overlaps between the three categories. The thing that does that is Venn diagrams, right? Venn diagrams is good at considering overlaps between different categories, right? And then you can work out the probabilities from that. Okay. And also to say, you're probably not going to get a probability tree diagram question anyway, because you had them in both papers. So yeah, you can reason it like that as well. Okay. Oh no, sorry. Let's go back. Uh, okay. Question 13. We're given some sort of arc, this sector question. We are told this diagram has a circle center O and radius 6.2. The area is 82.6. Find the angle X. Okay. So you should know the area of a sector, and I believe you have to remember this formula, but really the way to think about this formula is if we have an angle X here, for example, X, well, X over 360 is going to represent the proportion of the circle. So remember, a full circle goes the full 360 degrees, right? If we had a quarter circle here, well, it's a right angle, it's 90 degrees. So then 90 out of 360, so angle's 90. That simplifies to a quarter. That is saying we have a quarter of the full circle. So then if we adjust for a generic angle x over 360 is saying what proportion of the full circle we have. So therefore the area of a sector like this, again, all we did was cut off this other bit as well to give the full circle. So then the area is a proportion of a sector with an angle. It's just going to be a proportion of the full area of the circle. But the full area is just pi r squared. Okay. So this is saying this is a proportion x3 over 360 of the area is the area of the sector, right? Because the sector is literally just cutting off a part of the circle. So then the part of the circle we have is x over 360. Okay. So that's the area of the sector. So that's area of the sector. Okay. And so then we know the radius, but we also know the area of the sector. So we know, first of all, that this has to equal 82.6. But we also know the radius r is 6.2. So therefore, x over 360 times pi times 6.2 squared is going to be 82.6. Okay. Okay, then we can just simplify it a little bit. So we 6.2 squared, if it helps, that's going to be x over 360 times pi, and then 6.2 squared is 38.44, and that's going to equal 82.6. Okay. Then we need to solve for x. X is that angle. So then I'm going to divide x over 360. I'm going to divide by this, right? Pi times 38.44. So that's going to be 82.6 divided by pi times 38.44. And actually, that would get me, if we put that into the calculator then, 82.6 divided by pi times 38.44 gets you this number here, 0.683985 and so on. You shouldn't round yet though, because it actually wants you to give you round your answer at the end. But if you round too early, if you round too harshly, so if you round too few decimal places or whatever, it might affect your answer. So just keep this in mind in your calculator. But then x over 360 is going to be that number. So then if you just want x, you're going to times by 360. So it's going to be 360 times this 0.6839 that we got. And so put that so times 360 with that answer. You get x is 246.2347 2 and so on. But we need to round it to three significant figures. Well, it's going to be two. The significant figure, also remember, it's essentially a number, a digit, the digit that isn't zero. Okay, so that's the first significant figure. That's the second, and the 6 is the third. So it's going to be 246 degrees, 236, and that is going to be your answer. Okay. Cool. Now, bear in mind what I said at the start about a nasty geometry cell question at the end. They could again link sectors and stuff and missing angles like here with a trickier problem. So just bear that in mind. If you do see a nasty circle question, keep in mind that they haven't asked about sectors yet, and it might involve you having to work out a particular area or arc of a sector. But this is a sort of simpler question. Anyway, hopefully This sort of working makes sense. Okay, question 14 now. And again, they ask this is a quadratic sequence question. Asks us every year as well. It's going to come up, right? So just make sure you know the method to get the marks right. Okay, so we are given 6 terms. So we're on the nth term. Let's just write the terms out again. So 5, 11, 21, 35, 53, 75. Um, and so the nth term, remember, because it's a quadratic, it's going to look like a quadratic. So it's going to be an squared and bn plus c. Okay, so we've got the list. Now, what you're going to do is, again, if you have your own method for this, that's fine. But I'm going to go over the one I think probably is the best one, if I'm honest. Um, but again, if you have something that works for you, then that's fine. Anyway, so you then are going to consider, well, think about a linear sequence. How would you find a linear sequence like this? 5, 9, 13, 17, and so on. You'd consider the difference, right? And that would be the same number 4, 4, 4. Okay, and then you could go from there. That's exactly what we're going to do here. We're going to consider differences again. So the difference here is going to be 6. The difference here is going to be 10. The difference here is going to be 14, and then that's going to be 18, and then that's going to be 22. Well, unlike linear sequences, this is not a fixed number. But hopefully you notice it is actually now a linear sequence. So then if we consider the next difference, that's going to be 4, that's going to be 4, that's going to be 4, and that's going to be 4. So then now we have a fixed number, which is what we want. So if I say this is the first difference, and then the second difference here, wow, actually what that turns out to be is this number a here in front of the n squared, 2 lots of a is this number 4. Okay, this will always, always, always be the case. And you can think of this, if it helps, because this is the second difference, so it's going to be 2 lots of a. That's not the reason why particularly, but it helps you remember a second difference, so then 2 lots of a. Okay, so then therefore a is going to be 4 divided by 2, which is 2. Okay, so now we found a, so that's then going to be 2n squared at bn plus c. Cool. How are we going to find the other term, b and c, the other coefficients? Well, I'm going to write the sequence again. So 5, 11, 21, 35, 53, 75. What I'm then going to do then is take away this. If we're then going to generate a sequence of 2n squared. Okay, actually, so we're going to generate 2n squared. So that's when you plug in n is 1. So that's going to be 1 squared times 2, which is 2. Then 2, n is 2. Then 2 squared is 4. 4 times the 2 is going to be 8. Then when n is 3, it's going to be 3 squared, which is 9. Then 9 times 2 is going to be 18. Then n is 4, then 4 squared is 16, and times by 2 is 32. Then 5, 25, then that'd be 50. Then 6 squared is 36 times 2 is going to be 72. Okay. Then what I'm going to do is to take them away. Okay. I'm going to take the terms away term by term. So 5 take away 2 is going to be 3. 11 take away 8 is going to be 3. 21 take away 18 is going to be 3. 35 take away 32 is going to be 3. 53 divided by take away 53, and then 3 for the last one. It normally isn't a fixed number, but for this particular question, that's how it's happened. So what this gives us, this actually gives us another sequence. This is actually the sequence bn plus c, right? This linear part here. But actually it's a fixed number, so actually it's going up in zeros. So therefore b is 0. So then c, but if we go back by 1, it's still going to be 3, right? So then c is 3, and now we found our numbers. Okay, cool. So therefore, bring it all together. The nth term is 2n. Remember here, the nth term is 2n squared. Add 0n, well that would just be 0. Then you add 3 for c, and that's your nth term there. Okay, but it's a very weird example. It's a fixed number this time, but you do just get a linear one usually. And then the linear is exactly Bn plus c, the linear nth term. So then you, like we do with linear sequences, you find the nth term for that, and that will correspond to Bn plus c. Why that is the case, very briefly, well, this term here, the first term, that's a general term, 2n squared plus Bn plus c, right? That we found here. And then this term, the second bit, is 2n squared. I'm taking away 2n squared plus bn plus c by 2n squared effectively. That will cancel out. You'll just be left with bn plus c. That is why this remaining sequence we get from taking away gets us this sequence, okay? But yeah, that's the method, right? So you consider the first and the second differences to get 2a, get a. Then you generate the sequence for an squared to hit a is 2, so 2n squared. Then you take the original sequence away from it to then get the linear sequence to find b and c. Okay. 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 What time is it? 10:45 is okay. It's getting a bit late. Uh, I'm gonna have to leave it there, unfortunately. I started really late. I do apologise. I did start well for me quite late anyway. So I didn't have much time as much I'd like to do with it. But I did do part two to this. Okay. I didn't intend for this to be a two-part stream, but no, I did split it up just because my laptop can handle it. Because if I do less questions per sheet, I think my laptop will handle it a bit better because it's a bit downhill. But I just want time to do it all at least adequately anyway. I don't want to just absolute speed run it and like just rush it and just. I do want to explain it a bit, the questions, especially the harder ones coming up. But I'm going to do this tomorrow, okay? And I'm going to pick it up there. But in the meantime, if you do want to revise, and hopefully you should be, I'm just going to quickly jot down the predicted topics, okay? But I'm sure loads of people have done it already. I'm sure I'm not the only one to give this. So not the the predicted topics, but more specifically, I guess I know there's some huff and puff about predicted, the word predicted. I don't care about the word exactly. You get the idea. You can call it likely topics, whatever you want to call it. I don't really mind. Um, but the likely topics for paper 3, that's going to be, and I did note it down here. If these are the topics I recommend you go watch. However, sorry, to revise, but you can watch a video if you want. Like I said, Maths Gene is pretty good, or anyone else, however helps you. But the topics I'd highly recommend you go over, even though, like I said, should be everything. Error intervals, and it's going to be a lot of them actually. A lot of topics, bounds, and this is higher tier, by the way. Higher tier. Bounds, vectors, circle theorems. The best three topics every student likes, right? Bounds, vector, circle theorems. Yeah, it might be the hardest paper potentially. Anyway, indices, rearranging formulae, iteration. Now there was an iteration question on paper 2, but it looked like something like Pn plus 1 was k lots of Pn or something like that. The iteration I'm on about, and I'll show you what I'm on about very quickly, is to do with roots, okay? This sort of question. So you need to rearrange and then use it repeatedly to get a solution, right? Um, that's what I mean by iteration. Okay. But anyway, so iteration in that form will come up lightly. Compound interest, like I did just. And I'm going to also say reverse percentages. They're two distinct topics, but they can easily, like we just seen, merge them together as one. And they do like doing that. So make sure you know how to do both of them. Quadratic nth term, well, we just did. Angles and parallel lines. So again, that's your corresponding angles, your alternate angles, your co-interior angles. So angles that look like this. So that is your corresponding. That is your co-interior, and then that is your alternate. And then obviously you got your vertically opposite as well. So remember those four type of angles. Okay. So angle parallel lines, frustums. So that is referring to, I'll show you another question because I do have that prepared as well. That's looking at questions, where is it? Like this, right? So you essentially have a cone and then you cut off a cone on top of it. So then you're left with this sort of weird shape here. And this shape is a frustum, okay? So that's what I mean by that. Okay, that's frustum scattergraphs. Uh, and also potentially frequency polygon. It'd be one or the other. Okay. Uh, then plans and elevations. Oh God. Uh, plans and elevations. Averages from a frequency table, or particularly probably for higher anyway, mean and median from a frequency table. Okay, like we did earlier, right? From a frequency table. Um, Cumulative frequency. Uh, and then we're going to go down here. Speed. So that's speed, distance, time. I do think they're going to link it to bounds. They do like to do that on several past papers. Uh, and actually, there's a question I've got as well that I'm going to do tomorrow that I've already prepared for part two that will link both together, which I think would be a very likely question. So make sure you stick around for that. Pressure, again, like we did just it's actually pressure, area, and force. Perpendicular parallel lines. Venn diagrams. Now, bear in mind, like we just saw, they do not. It might not give you a Venn diagram. You might have to work out as a Venn diagram question and draw it. Okay. Depends on how nasty they're feeling. So that's Venn diagrams. Capture, recapture. Um, So that's essentially saying if we have a sample of some sort of population, like animal, for example, if we take a sample and put some dye on it or tag it, put a tag on some of them, then we can estimate the whole population, how many there are in total, um, by then taking another sample, essentially, and then see how many of the tagged animals come back. But we will see a question like that tomorrow as well. Capture, recapture, algebraic fractions. And this will be both solving and simplifying. Okay. So obviously simplify is going to look something like this. Let me get the question. Like this, right? So you have some nasty fractions and then you simplify it to a single fraction like this. Or you could solve them. So you could have something like 6x over x squared, well, x plus 1 squared or something like that. and that equals, I don't know, 3x over x minus 1 or something like that. I don't know. And then you have to cross multiply and then solve for x. Okay, either or could come up. So make sure you really are really proficient with your algebraic fractions. Again, areas slash arcs of a sector. So a sector of a circle. Trig graphs. So natural sine, cos, and tan. So obviously sine is going to look like this. Uh, Cos is going to look like this, and tan is going to look like this, right? And it has an asymptote at 90. Again, that's your tan graph. Okay. So you need to remember those graphs as well. I reckon they might ask you to sketch it. They might ask you to also transform it a graph. Okay, so I'm going to say this could be linked to graph transformations. Okay, so you might have to shift it, translate it, or stretch it by scale factor. So you have to shrink or widen the coordinates. So, for example, sine of 2x. That would mean you have to halve the x coordinates, right? So you have to divide by 2. That's what that's saying. So then you have to sketch that sort of graph. Congruent triangles. So proving two triangles are congruent, which essentially means they're exactly the same. Okay, so all the same lengths and the same sides, same angles and the same sides. But they might just be rearranged a bit differently by like rotating. So for example, I don't know, these triangles could be equal in length and angles, but they're just orientated. Hang on, let me sketch it a bit better. But they're just like rotated a bit. But you need to prove that they're the same, and that's going to be your using either. Obviously, that's going to be angle, side angle. So either two angles, uh, two sides. No, actually, I want to get this. I want to get this bang on right. Uh, yeah, two sides, two sides and an angle, two angles and a side, three sides, um, and yeah, or what you cannot have is three angles. You cannot have three angles. And you looked at that in paper one. If two triangles have all the same angles, that doesn't mean all the sides are the same length. What it means is they're similar. So they all the sides differ by a scale factor, but not that the angles are all the same. Okay, and not that all the sides are the same. But if the angles are all the same, they're not congruent necessarily because they differ by scale factor. But if all the sides are the same, then all the angles are the same and it's congruent. Okay. In the only case when you have no, sorry, or alternatively, you for the last bit you have a right angle triangle. So if two right angle triangles are the same, they both have a right angle, of course, because they're right angles. The hypotenuse is the same in both, and another side is the same as well. Um, okay, so it's basically just angle. That's essentially a specific case of angle side, right? Because hypotenuse is the side as well. Anyway, so remember that and how you prove two triangles congruent by one of these four rules. Okay, what else? Simultaneous equations. So that's linear or quadratic. Okay. So make sure you know how to solve both of them. What else? Bearings potentially. Now they did already ask a nasty not Sokotoa, sine and cosine rule question in paper two. So I would expect a massively complicated bearings question, like I've seen in the past. They don't normally come up actually, to be honest. They're not. But all you have to remember is really, it's a particular type of angle where we measure from the north and then obviously we go from there, right? So we go all the way around to 360 that way. So for example, if we had an angle here that was here, which will say 30, so that so then the bearing would be here, then that'd be 90, and then that would be the full rotation would be 180, right? So 30, all of this would be 150, right? So then the bearing would be 150. So the angle or bearing would be 150. Okay. Because we measure from the north. Okay. That's to get to this angle here. Okay. So that's bearings. Again, they might get a small or 2 mark question come up on that. I don't know. I wouldn't expect a nasty question, but I don't know. And then some really particular, but then there's some questions that haven't been assessed. Well, I mean, they're not really, but I don't think they're likely to come up. And these are okay. So these are the major important topics. Again, I would zoom out, but I think it'd be too small to see otherwise to get all the topics in. I'll zoom out even. Oh, not like that. I don't know, something like that. If you can see the likely topics, if you want to screenshot it or do whatever, I don't know. Um, so those are the topics, and actually, those are counted. They are about they are 24 topics there. Okay, and actually, that corresponds to basically a whole paper's worth of questions, right? So though all of them, what I mean, they could be a paper. Um, but there's a few minor topics. Well, that could also come up because they haven't really come up, but they're not as likely. I'm going to zoom in now so you can see it a bit better. And one of those is actually going to be using a calculator. So that's your basic 2 markers. Like, write all the do this sort of sum, right? 19.9 cubed at sine 40 all over 2.7 cubed minus, I don't know, uh, pi. I don't know, something like that. Where you just have to put the most random stuff in the calculator and then you have to write all the digits you get. That could come up, but I think by paper 3, it's a bit weird asking you how to use a calculator when there's already been a paper where you needed to use a calculator. So I don't know. They could ask it either way. It shouldn't be too much hassle. But then you could also be asked uh, hard probability. So I'm going to say probability algebra question, which normally comes up at the end of a paper. So that's stuff like where it's basically like a tree diagram, some mostly, but it's with algebraic fractions, which could link into the algebraic fractions I talked about earlier potentially. But there was a kind of hard probability question in paper 1, so I'm not sure. Like, but I don't know. I don't put that as high, especially when there's a lot of probability questions already. I'm not entirely sure. Also, circle theorem proofs. Um, Now, this is an interesting topic. It's a grade 9 topic, but you actually do need to know how to prove the circle theorems. But they never ask it. I think this is one of the topics that examiners just like unofficially take it off the spec. I don't know. It's like they have to put it on the spec officially, but they never asked it. I think they only said it in like one past paper. But I've never. I don't think I've seen a question on it yet, really, on the past papers I've looked for to get questions. It doesn't come up really. So if you're really struggling, you just can't do a proof or anything like that, just leave it. If I'm completely honest, it's not normally about 4 marks. I think probably. I mean, yes, it might look like a lot of marks. I get every mark counts, but if you're going to spend so much time trying to just do this one topic of proving the circle theorems, I do think there's better time spent on practicing all the other topics, especially when this doesn't really come up. And the other one potentially could be to do with circle, like tangent and radius of a circle. So that's obviously the equation of a circle, and then obviously given the tangent, and then you need to use the fact the radius is perpendicular, and then you find the gradients, and then you intersect, and then the perpendicular, then you intersect, and then get then you get the intersection point, and then do it from there. And that's sort of a grade 9 topic as well, and towards the end of the paper. But there was already a circle question already in paper 2, not full on like this. So I don't know, but it could come up. And obviously the last question, well, it's not really a topic. I'm not going to write it down, but you could get an absolutely nasty circle question at the end. That I can't really help you with. I don't think many people can. You just really need to learn you need to learn all the geometric topics really well, essentially, to tackle that. But these are the main topics I just said, and obviously these are a few not minor, but the less likely ones, but should practice as with every other topic. But yeah, that's everything that I think should come up in paper 3, thereabouts anyway. But I'm going to leave that there then. For now, I'm going to pick up questions in part 2 of this tomorrow and tackle the other questions I've got for this here. But yeah, I'll see you next time.